Alright, this video is we're gonna work through basic skills quiz, the second one. This was just from last week, and it's to help you just continue to practice as the quarter goes on. Remember, you have the opportunity to take up to 10 of these this quarter, and it's the average of your best 3 that count. So here we go, and I would, as we go through this, don't just watch me do it. What you might want to do is, before I even get started, try it out and then use the video to help you progress through that, or to check your work. All right, so first one is a factoring problem. Last week for Basic Skills 1, I showed you the guess and check, which is basically starting out with the 2 sets of parentheses and taking an educated guess at what the distribution is going to work out to be, and then checking in it. If it doesn't work, you make adjustments as you go. So if you like that one, or just want to practice that some more, go back to that video and look through that one. I am going to do the A times C grouping method today. Okay, so some of you, instead of guessing and check, might prefer this because it's a little more procedural. Okay, so I call it A times C grouping because the first step, you want to multiply the A. Remember, like in your quadratic formula, A is 3, B is 18, and C is 15. So if we multiply 3 times 15, remember, you're not allowed to use your calculators on this, it's 45. So if you couldn't do that in your head, just write it out on paper and multiply it out. 45. Now we want to think of 2 factors of 45 that add up to 18, that add up to that B value there. So let's see. Well, 45. Well, the first thing that comes to mind, and it's just how we got this, was 3 and 15. It doesn't always work out that way. What are some other ways to multiply to be 45? Doesn't 9 times 5 multiply to be 45? 1 times 45? But here's the deal. We want to see which of these factor pairs, add up to 18. So as you look at that, it's this pair that adds up to 18. Okay? So once you've multiplied A times C and you've found out the factor pair that adds up to this B value, you're going to rewrite this trinomial here. So it starts with 3x squared. It ends with 15, and in the middle we have 18x. I'm not going to write 18x the way I see it here. I'm going to write it with this factor pair. That right there still says 18x. Okay? So we've multiplied A times C. We found the factor pair. We rewrote this. From here on out, it's 2 steps of common factors, common factor once, common factor again, and we're done right here on this step. Okay? So you want to group together the first 2 and the last 2 terms, and you want to look for common factors here. The greatest common factor, 3 and x factors out of this, 3 and x. So if I factor a 3x out of this pair, remember factoring means dividing out, so if I divide out a 3 and an x out of here, I'm only left with 1x. And if I divide this by 3 and x, what's 3x divided by 3x? 1. And you can always check your work by just in your head distributing it back, see if it equals this. So let 3x times x, 3x squared, 3x times 1, 3x. Plus, now we want to look for a common factor here. And I think you see it, 15 is the common factor. So if we factor out a 15 or divide 15 out of here, we're left with x. And if we divide out or factor out a 15 out of here, 15 divided by 15 is 1. Notice these are the same. That means you're heading in the right direction to be done here. Okay? So now we have one more step of common factors, and it has to do with this like pair here. X plus 1 and x plus 1 are common factors between this term and that term. So if we factor out an x plus 1, what we're left with, factor out x plus 1 out of here, we're left with 3x. Factor out x plus 1 out of here, we're left with 15. Done. Okay? 30, 60, 90 triangle, we're given the short leg. That's the most important side. If you don't know that first, this is the first one you need to figure out. But we know this one. Okay? So the relationship between the short leg and the hypotenuse is a factor of 2. If you're going to a bigger side, you're going to multiply by 2, and if you're going to a smaller side, you're dividing by 2. So we're going to a bigger side here, so 11 times 2 is 22, so that's the hypotenuse. The relationship between the short leg and the long leg is a factor of radical 3. If you're going to a bigger side, you're going to multiply by radical 3, smaller side dividing. This side is bigger than 11. You can see it. Okay? So we're going to multiply 11 times the square root of 3. That says 11 times the square root of 3, and that is the length of that side. Done. All right, moving on. Graph the inverse. So that's a reflection over the line y equals x, but we have a shorter way of doing this. We're going to find some coordinate points on this function right here, and those are the ones that I can see for sure. And so we know if we reflect across the line y equals x, the coordinates switch. So this has the coordinates 0, 3. So if I switch those, 3, 0, that's part of the inverse. This has the coordinates 5, 1. So if I switch those, 1, 5, that's another one. We can already see where that line's going to be, okay? But if we need to, this is negative 5, positive 5. So if we switch those, 5, negative 5. So 5, negative 5 is right here. Get on my straight edge. And there's our inverse right there. Okay, so we just switch the x and y coordinates to get the inverse. This is the algebraic inverse. So here we go. We're going to take this out of function notation. And now we're going to take the inverse. Well, if switching x and y finds our inverse here, then switching x and y will find our inverse here. That's the inverse, but we just have to get y by itself and write it back in function notation. So square root both sides. Square root undoes a square. So the square root of the right-hand side and the square root of the left-hand side, we have to remember that plus or minus. And then get y by itself. How do you undo that subtraction? Add 6 to this side, add 6 to this side. Y is by itself. We need to get it back into function notation. This is f of x. We've just found its inverse. So the way you say this is f inverse of x. It is the inverse of this function. So it's 6 plus or minus radical x. All right, next one. Adding fractions. So we need a common denominator. We're going to make that happen. That fraction has a value of 1. It's not going to change the value of 8/7, just the look. This fraction has a value of 1. So 8/7 is going to be rewritten as 24 21sts, and 2/3 is going to be rewritten as 14 21sts, for a total of how many 21sts? It looks like 38 21sts. All right, let's see. We have to first decide whether this is repeated addition, which would be linear, y equals mx plus b. That was on Skills Quiz 1. Go back to that if you need to see it. Or multiplication, repeated multiplication. And that's what's happening here. So 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So this is a repeated multiplication of 3. All right, so this is exponential. Last week's, again, go back to that video. That was repeated addition, which is y equals mx plus b, a linear equation. This is exponential, and we've said this quite a few times. Starting amount, multiplier, number of times you're going to use the multiplier. So here's your starting amount. Starting amount was when time is 0. You can think about the x value as time if you want. Starting amount is 6. The multiplier, what are we repeatedly multiplying by? The multiplier is 3. And how many times we use the multiplier varies. Okay? So here's our equation. We can check it. If we plug in a 2, we should get a 54. So if I put a 2 there, 3 squared is 9, times 6 is 54. You can check it a couple more times. It works. All right, here's a 45, 45, 90. We're told that the hypotenuse is 10 radical, or a 7 radical 10. This comes from a square, so these two sides are the same. And the relationship, the factor between the hypotenuse and the legs is the square root of 2. If you're going to a smaller side, you divide by radical 2. If you're going to a bigger side, you multiply by radical 2. These sides are smaller than the hypotenuse, so we're going to take 7 radical 10 and divide it by the square root of 2. So honestly, if you wrote 7 radical 10 over radical 2 here and here, that would be correct. I would not mark those wrong. I'm going to model kind of correct reducing behavior here. You don't have to, but the square, just like 10 over 2 is 5 over 1, the square root of 10 divided by the square root of 2 is the square root of 5 over 1. So I'm just going to write these as 7 radical 5. But again, if you put that value here and here, it's the same thing. Okay. All right. SOHCAHTOA, right triangle trigonometry. Theta is up here. So this is the opposite side, this is the hypotenuse, and this is the adjacent. So the sine is the opposite over hypotenuse, 20 over 29. The cosine is the adjacent over hypotenuse, 21 over 29. And the tangent is the opposite over adjacent. All right, there's the skills quiz. Practice and be ready for the next one. Good luck, guys.